Hello everyone, and I hope you are doing well everywhere you are. I'm so glad that I'm here in another video to discuss about another feature of mesh creation. Actually, in this video I'm gonna be talking about the interface between two adjacent zones. For example, consider that you have fluid zones and you wanna make a connection between them in order to transfer data in your numerical simulation. So you have to define such a connection. When I'm talking about an interface, I don't mean the interface boundary condition necessarily. I mean the meaning of interface in general. And as Lyman says, the surface where two things touch each other. So you can create an interior boundary condition or an interface boundary condition in such a connection. Actually, it highly depends on the complexity of the geometry as well as the accuracy you want to reach in your numerical simulation. So if the mesh elements match on such an interface, it's gonna be great. If don't, you have another option. So I'm gonna be talking about these situations in detail. As you can see here, there are two adjacent zones and they could be fluid-solid, or solid-solid. And now I'm going to be talking about how to assign an appropriate boundary condition to this interface, a wall, an interior, or an interface boundary condition. In terms of transition between the two zones, there are two types of mesh, conformal and non-conformal mesh. In a conformal mesh, all mesh nodes match together. As you can see here, all mesh nodes are located on the same place, and so there is no need to do interpolation for transferring data between one side to the other. And this is another example of a conformal mesh. You know, in a conformal mesh, you cannot create the interface boundary condition, and it's gonna be great because that's what we want. Because there is no need to do interpolation and the accuracy of numerical simulation will be survived. Another mesh type is non-conformal. As you can see here, the nodes don't match. They are not located on the same point, and so for transferring data from one side to the other, an interpolation should be done. And you have to create the interface boundary condition for such a mesh type. Now, you should assign a boundary condition based on the type of your mesh. When you have a conformal mesh, you can create interior or wall based on the type of your zones. When you have fluid zones, you can create interior boundary condition. For example, as you can see here, if I enable the mesh and use wireframe, this is an example of a conformal mesh, and if the two zones are fluid, you can assign the interior boundary condition for the interface between two zones. And if one side is solid, for example, for fluid solid or for solid solid, you must assign a wall boundary condition for the interface. And when your mesh is non-conformal, when mesh elements do not match, you have to create the interface boundary condition. And it doesn't matter what type of zones are adjacent, fluid, solid, or solid. You have to assign the interface boundary condition for the interface. Now, what we want is avoiding the creation of interface boundary condition, because it will impose some errors and inaccuracies in our numerical simulation. And now there are three solutions to this issue. When you want to create mesh, it is recommended that you create a structured mesh for both zones if it's possible. For example, this mesh type is hexahedral structured mesh for both zones, and this is an ideal mesh. And you can easily create a conformal mesh between the transition surface. But in some situation it's impossible because of the complexity of the geometry. So it is recommended that you create unstructured mesh type for both zones. And if you do this simultaneously, you can achieve a conformal mesh. And it's straightforward. But if you want to create the structure type for one side and the unstructured type for the other side, you should be careful, because you have to merge nodes after mesh creation. Create the structured mesh firstly and then the unstructured type. And then you can merge the nodes in order to achieve a conformal mesh type. And you must notice that the mesh size for unstructured side must be smaller than the structured side in order to merge nodes. And ANSYS ICEM-CFD gives you a robust tool to do this. You can use the edit mesh and merge nodes to do this procedure. Okay, you can merge surface mesh parts. For example, imagine that we have structured type for this zone and unstructured type for the other. So I choose wall in between. This is the interface. And for frozen volume mesh parts, you should choose the structured type, because the quality of mesh is better for the structured side. And then you apply and you will be given the best results. Just you must notice that you can do this only so far away from the walls where you don't need to create prism layers, because you can only use this option when all mesh elements on the unstructured type is triangular on the surface, and so quad elements are not supported. So in the unstructured part, you should not have any prism layers. So I recommend you that you only use hybrid mesh, structured and unstructured, so far away from the walls where you do not need to create prism layers, and so you can merge the nodes easily. Okay? Thank you so much for your watching, and if you have any question about this issue, please leave me a comment. Or you can send me an email to infinitycfd@gmail.com. Thank you so much for your watching.